Starting with the name of Allah, who is the most merciful and beneficent. Today I'm here to present our FYP project presentation, which is based on the title Design and Performance of Differential Relay with Experimental Validation. And we have worked under the supervision of Sir Shoaib Ahmed Sheikh and Sir Muhammad Fawad Sheikh. Myself is Gulmar Shah, along with my team member Kashifullah. The content for today, the roadmap could be, first we will do introduction, then the motivation behind this project and a problem statement for this project, and the aims and objective which we have achieved, we will be going to achieve, and the methodology which we have applied throughout this FYP chapter, and then the results and discussions and conclusion and future recommendation, and final the references from where we have took the ideas. Introduction. As you know, the technology has been everywhere, from our home appliances to the industrial, where different type of machines are running, and this machine there needs some protections. In the same way, various protections are applied in the power system, but the main reason of this protection is to isolate the faulty system from the rest of the system in order to have continuity of the supply. Our project include the same protections for this power system, which is differential protection, which could be more efficient and control protection to any part of the system. In this project, we have designed a unique algorithm-based differential protection, which is based on a microcontroller where we use Arduino, which we program this for protections of transformer, generator, transmission line, motor, and bus bar. In order to have secure protections for this, we designed this differential relay with the help of Arduino as a microcontroller. A differential relay is one that operates when the vector difference of two or more similar electrical quantity exceed a predetermined value. And the differential current is compared at the input side and at the output side of the junctions. And if there is a difference between the incoming and outgoing current flow through the operating coil, the difference will be created and the relay will generate a trap signal to circuit breaker in order to isolate the faulty system from the rest of the system. If this difference of current is greater than the pickoff value, which we have set it in the setting, then the relay will operate and the circuit breaker will isolate the faulty section. Now, the motivation behind this project, we have been motivated in order to design a differential relay which could operate depending on the difference between two or more similar electrical quantity, and this differential relay will work for transformer, transmission line, bus bar, motor, generator, and all other equipments which are related in the lab. And the motivation also was this, to design a relay which could be programmable and provide required protections with the help of keypad when user enter. And this motivation was also to design a lay purpose trainer of differential relay. The problem statement. Number one, no differential relay is available in the market for lab purpose, which is capable of doing differential protections of all lab equipments. The second, lack of differential relay trainer for lab purpose. The third, differential relay for lab purpose are very costly. That's why these were the problem statement. Now the aims and objective of our project were detecting internal fault of equipments, This differential relay detect the internal fault in the equipments, and this was the aims or to detect any internal fault in the system, and this differential relay will provide protection to that. The second one was to isolation of faulty sections. When the fault occur in the internal system, if even this could be a generator, transformer, motor, transmission line, this differential relay with the help of circuit breaker will isolate the faulty sections from the rest of the section. Differential relay for lay purpose. Our aim was to design such a differential relay for lay purpose where it could work as a trainer in order to have the required protection like transformer, generator, motor, bus bar. And this could be entered with the help of keypad. As most of the relays are very costly, and we have designed this differential relay, and this is economical and cost efficient. The methodology throughout this chapter of FYP is as first, we have been through MATLAB simulation. We have done simulation of transformer, bus bar, transmission line, static load, generator, motor. And after the simulation of MATLAB, we have come to Proteus. And there we have done transmission line simulation, generator simulation, transformer simulations. And for the sake of this, we have worked on the Proteus because there was Arduino interface, and in a real time we need coding, and this we did coding in Proteus with the help of Arduino. And we did coding for transformer, coding for transmission line, static load, generator, and motor. And after implementing these in a Proteus, and the results were quite impressive, we then came to hardware implementation. And testing phase of differential relay, individual base we did for every protective unit like generator, motor, transformer. And then we done combined, did the code combined with the help of keypad. We selected the required protections, and with the help of this, we done protections of the combined. Then we designed solid work design for this differential relay in order to give a proper shape. And then after the designing, we assemble the components and give a finished product. The flow chart was where we have started from the MATLAB simulations, and we have been through all these steps, and we reached to the Proteus simulations. And after the Proteus simulations, for that we did Arduino programming for each and every one equipment. And then we have been through hardware implementation, where we have implemented the hardware, which we have given the final shape. And this was the flow chart for this. Then as we have worked on the MATLAB, and this is the simulations of the MATLAB. This is the power supply, three-phase power supply, and this is its variable supply, because through this knob we can vary the voltages of this three-phase power supply. And this is the LCD or display where we can see the voltages of this power supply. This is the input CT and PT, where we can measure the voltages of this three-phase power supply. And this is the the transformer, which is going to be protected with the help of this differential relay. In the either side of this transformer, we have used input CT with the circuit breaker and output CT with the circuit breaker. And this is the load, which is variable. Through this knob we can vary the loads. This is the displays for the currents, and this is the display for the voltages, which is we receive the voltages and current from this CT and PT, and this from this CT and PT we receive the voltages and current over here. And the voltages are the amperes which we receive, which is drawn by this load, we receive over here and we see here. And this is the ratio of current where the input and output current is matched, and this is there is display this, and this is toggle button which we have used. This is for the sake of the when the once the circuit breaker are open and the MATLAB it cannot reclose by itself. So we use this toggle in order to maintain the system stability again and to bring the system to the healthy part after the fault is injected. This is the control center and monitoring center, where in the control center we have the input current, which with the help of RMS, which we get the RMS value of this input current and output current, where we have did the logic in order to give the ratio where I have discussed previously, the current ratio of input and output, and with the help of this sum we plus and minus, where we get the required value, and with the help of this absolute, where we get the positive value, and we have put the limit 0.5. If the current difference exceeds from the 0.5, the differential relay will trip, and this is the JK flip-flop, and we use AND gate. If there is any input is 0, it will generate 1, and with the help of 1, the relay will not trip. And if all these are 1, 1, 0, 0, 0, the differential relay will operate and will generate 0, and the circuit breaker will. No, this is the monitoring center where we monitor input current, output current, and input voltages, output voltages, and the supply voltages, along with in the phase differences. This is the 3-phase supply which we have designed, which we have input voltages, phase angle, and frequencies. And this is the variable load which we have designed. Now the busbar simulation, which we have done the same as everything are same, but this is our busbar where we have 2 feeder, this one and this one is the feeder. And this is the circuit breaker along with the CT, and this is the circuit breaker along with the CT, and this is the circuit breaker along with the CT, and all the displays are the same. And this is the control center for busbar simulation, which has the input current from the feeder 1 and output current from the feeder 1 and output current from the feeder 2, and this is the input current to the feeder. This is transmission line simulations which we have done, and all the displays are the same for the currents and the voltages. And this is the transmission line which we have used 2 transmission line, and other side that there are current CTs and PDs along with the load. And this is a control center. We doing control for the relay in order to give 0 and 1. We received 1 and 0 with the help of this control center, and this 0 and 1 is given to circuit breaker. This is the generator simulations, and which we have done, all are the same. And this is the control center where we made a different type of logic, and with the help of this phase 0. And this is the same generator simulation where we have simulated the generators, and we have PM controller and exciter and circuit breakers, where we see the differences of the current here. And the same, this is the load which draws current from this. And this is the control center for the generator, and this is the logic which we have made for. Now, after the simulation in MATLAB, we have come to the Proteus work in order to see this behavior. This is the code flow chart where we take variables, we define variable in libraries, and then define input pins for the current sensor in Arduino, and then select the required protection with the help of keypad. When the user enter 1, it will give protection to transformer. Then if it is 2, transmission line protection, and if the user give input 3, then it will give generator and motor, and 4 busbar. and the decision will be taken by microcontroller. If the transformer someone is enter the transformer protection, then decision will be taken on the transformer. If there is no fault, then the protection will be continued. If there is fault, the generators trip signal to CB and the system will be terminated. In the same way, these all are. This is the simulations and the purchase which we have done, and this is the simulation for transformer simulation, where we have three-phase supply, and this is the current sensor, and this is the transformer. This is 3 input current sensor and 3 output current sensor, and this is the Arduino which we have used for, and this is the where we can give fault to the transformer. This is transmission line simulation. The same way we have 6 current sensor, Arduino, and the display LCD, where we can see the input current, output current, and the status of our differential relay, whether it is faulty or not. And this is the generator simulations. After simulation successfully done and purchase, we come to do testing of our differential relay. First, we did with the transmission line protections, which we have used current sensors, which are very small, because this was a testing phase, and then we go to motor protections, and we done protection of motor and then transformer protection, and the result were good enough. Then we moved to SolidWorks design, because everything was quite good. Then we designed our differential relay in SolidWorks. This is the final shape of differential relay in SolidWorks. After giving a proper shape, we started working on it, and we work on a differential relay, and then we started taking the results. Yeah. After testing successfully, we moved to SolidWorks design in order to give a proper shape to our differential relay. And this is the final shape of our differential relay in Fortis, where we have a symbol, the front view, back view, and top view. No result and discussions. First, we did MATLAB simulation. So the MATLAB simulation results were like this. For transformer differential protection, this is the healthy system which we have run, and this is the output waveform. This is the input waveform, and this is the output waveform of each input phase current, and this is the output current phase A, B, C. This is the faulty system where it shows the circuit breaker is tripped, because this is the status, the rate that showed that your circuit breaker has tripped, and this is the output waveform where the fault occur at 0.5 second. Now, this is the busbar differential protection, this is the healthy system, and the waveform is quite impressive. This is the input, and this is the output of feeder 1. This is the output of feeder 2. And this is the faulty system where it shows the circuit breaker are tripped, and this is a rate. The status shows that a rate that the circuit breaker are tripped. This is the input current waveform, and these are the output current waveform. This feeder 1, feeder 2. Same as transmission line differential protection, which we have done, and this is the healthy system, and this is its waveform, and this is faulty system, and its waveform where the fault we have injected is 0.2 second. This is the generator differential protection where there is a healthy system, and this is the waveform of this healthy system, and this is the faulty system, and this is its waveform where fault occur at 0.2 second. Now, this is the static load differential protection with the healthy system and the faulty system along with its output waveform. Now, after the MATLAB simulation, we have been to purchase result and discussion. This is the healthy system where we can see there is no fault in our system, and the current input, which is I1, I2, I3, almost equal to 0.32 to the output of I4, I5, and I6. This is the Arduino where we did coding, and these are current sensor, these are input current sensor, and these are output current sensor, which we have connected with L1 as with the relay, and this is then connected to this, and its output, it is CT1, and we have connected CT1 to the A0 pin of the Arduino. And this is the same, its output is connected with this one, and this is 111 is connected with now this is the Proteus simulation where we have simulated the transmission line differential protection. This is the healthy system where we have three-phase supply, and these are meter which measure the current. And after the meter connections, we have connected series. These are 3 input CD and these are 3 output CD, and its connection is connected with the input of the positive side of the CD, and this output is connected with this. And after it's the output current, because this is the transmission line, and its output is connected with the help of this relay, and the in point is connected with this. And if you can see that input I1, I2, I3, and output I4, I5, I6 are all equal in magnitude, and there is no fault in the system. And with the help of this microcontroller, we have connected all cities A0, A1, A2, A3, A4, A5, and these are all connected with this Arduino. And this is the Arduino where we have embedded our code, which we have done with. This is the faulty system where the current exceeds from the predetermined value of 0.05, and the difference are 0.1, and fault occur in phase A. Because the current exceeded from the predetermined value, after the difference we have seen there, the difference was 0.1, which is the faulty system, and it shows that the fault is occur at P1. This is the generator differential protection, and this is the healthy system of this differential protection, and this is the faulty system. In the healthy system, the current is quite impressive, and it shows there is no fault. In the faulty system, the difference exceed, and they are showed with the fault. This is transformer differential protections, which show there is no fault and all input and output current are equal. And this is the faulty system where different occur, and the different are 0.33, and it showed that the fault is in the system in the relay tripped. Final design, which we have given after the MATLAB simulation and purchase simulations. This is the final shape, our differential protections, where we have this is the full line of input CD, and this is the full line of output side. And these are the 2 meters, same meter which measure the current, and this measure the input current, this measure the output current. This is the display LCD where we can see the means different types currents where we can see, and this also it shows the relays loading. You can select transmission line protection, motor or generator protection, transformer protection. And with the help of this keypad, user can give instruction to differential relay which protection I want. This is the assembling. We have assembled our differential protection, different components in it. This is ready for proposed protection. The differential relay was ready, and we have tested with this, and it showed the results. Here are some tested which we have done with the help of this differential relay. First is transformer protection, which we have designed in the lab, and we have seen its performance. Now let's have a video. differential protection where we have tested. This is the transmission line protection where we have designed in the lab and we have seen its result were quite impressive. And have a look to this video. Have a look to the last motor protection where we have designed the differential protection for motor and the lab, and we have successfully done with this too. Let's have a look to this one. These were hardware-based testing, which we have tested our differential relay in the lab after giving a final shape. Conclusion and future recommendation. In this project, we designed a differential relay which is cheap in cost and programmable, dynamic in nature. And it required less maintenance because we used current sensors for that, which is not too much costly, and my microcontroller, which is Arduino. To get result, we used two software, Simulink and as well as lab hardware. We tested our differential relay simulations and found that the result at a healthy system and faulty system at both. When the system was faulty and the system was healthy at both, we tested our differential relay and in simulations, and the results were quite impressive. Then we tested our differential relay on the lab equipments where we have given differential protection to generator, motor, transformer, transmission line, and also these results were up to the mark and gives proper protections. Study the programmable relay was to detect an internal fault and tap the system immediately. We see that when the system there was any difference occur in for the differential relay, if their difference exceed from 0.05, the differential relay immediately act and found out that there is a difference in the system, was isolated with the help of circuit breaker. In future recommendation, as this was all in one differential relay scheme for lab purpose only, which could be used as a trainer, but our future recommendation is to design such differential relay which will be capable of doing protections of high rating, because this differential relay is only for lab purpose where we use low voltages and low current. But this is the recommendations that a differential relay such which could be dynamic, programmable, and could be used for protections of different equipments in the power system will be designed but for high rating. To design IoT based where it could be controlled from far off, and to replace the Arduino Uno with the Raspberry Pi, because this Arduino Uno is not much capable to have a lot of coding, because our coding was a lot. Due to this, we would like to replace this Arduino Uno with the Raspberry Pi. No references. These were some references from where we have taken the ideas, how to have been through these all chapters. Thank you so much.